In this video, we're going to be looking at solving logarithmic equations with multiple logs on one side. So to solve these, we're going to go through basically 4 different steps. The first step is we're going to combine the logarithms using our properties of logs that we learned before. And so remember, that was like that product property where if I had log x plus log y, the same thing as log times xy, or the quotient property where it would be the same thing as division, and that power property. Step 2 is to rewrite as an exponential if you want to go through it, that method on the blue, or if you want to use the purple method, you can take the common log. Step 3, simplify and solve, and then step 4, we're going to check for extraneous solutions. Because with logs, we need to remember that we cannot take the log of a negative number. So if you end up with a negative answer and say that means that you're going to take log of, let's say you got -5, this is undefined. So that would mean that x equals -5 is not a solution. It's actually going to be an extraneous solution. So we're going to make sure we check our work and see whether these solutions are legitimate or not. Okay, so number 1, I have log 2x plus log of x minus 5 is equal to 2. First step is I want to combine those logs using the product property of logarithms, and that told me that this is going to be equivalent to log of 2x times x minus 5 is equal to 2. And now I want to get rid of that log. And so we looked at in the previous video, with log, I have a base of 10. So that means I can have 10 be my base and take this equation and put it into my exponent. Oops, sorry. This right hand side should be 2. And so when I do that, this 10 raised to the log cancels out, so I'm left with 2x times x minus 5 on the left-hand side. 10 squared, I get 100. And now I need to solve this equation. Well, 2x times x, I get 2x squared. And then 2x times -5, I get negative 10x. Equal to 100. And now I have a quadratic equation, and so I know for a quadratic I need all my terms on one side, so I'm going to subtract 100 from both sides, and I get 2x squared minus 10x minus 100 is equal to 0. And I'm going to go ahead and factor this, but first I see there is a GCF of 2, so I'm going to go ahead and divide everything by 2 just to make this a little simpler for me. And so I have x squared minus 5x minus 50 is equal to 0. And now I need to factor this. And so I'm looking for 2 numbers that multiply to -50 and add to -5. And I find that's going to be -10 and +5. -10 times 5, I get -50. -10 plus 5, I get -5. And so now from here, I have 2 equations that I need to solve. I have x minus 10 is equal to 0, or x plus 5 is equal to 0. And when I solve both of those, I get 10 and -5. But now to see whether both of these are legitimate solutions, or whether one of them is going to be, or both is going to be extraneous. Well, I see with 10, when I plug it in, I get log 10 and log 5. So both of those are positive numbers in there, so that one's good. However, when I plug in -5 into log of 2x, I get log of -10. And log of -10 is undefined. So this is going to be extraneous. So that means my only solution here is x is equal to 10. And again, that's because log of 2 times negative 5 is equal to log of negative 10, which is undefined. Okay, let's try this next one. So next one I have log of 2x squared minus log of 5 is equal to 1. So here I have the quotient property that I'm going to be using. The quotient property tells me that this is equal to log of 2x squared divided by 5 is equal to 1. And now I need to get rid of that log. And so here that is base 10, so that means this is going to be the same thing as 10 raised to the log of 2x squared over 5 and 10 raised to the 1. My 10 raised to the log cancels out, so I'm left with 2x squared over 5 is equal to 10. And then now I need to solve this, so I can go ahead and multiply both sides by 5 to get rid of divide by 5. And I get 2x squared is equal to 50. Divide by 2, and I get x squared is equal to 25. Take the square root, and I get x is equal to plus or minus 5. But now I need to go ahead and plug those in to see whether I get a negative log or not, because if I do, then that is going to be an extraneous solution. Well, when I put in x equals 5, I have log of 2 times 5 squared, which gives me log of 50, so that is good. When I plug in x equals negative 5, I have log of 2 negative 5 squared, which is also log of 50, because negative 5 squared, I get a positive 25, which then is multiplied by 2 is positive 50. So actually both of these solutions are legitimate solutions. So the answer here is going to be both positive and negative 5. Okay, let's look at one last one. So this last one I have log base 4 of x plus 12 plus log base 4 of x is equal to 3. This time I'm going to go ahead and do the exponential form to solve this, just so we can look at that method to use again, since you can use either one to solve these types of problems. But my first step is going to be the same. I want to combine these logs, and so this is the product property again, so that means I'm going to be multiplying those together. So I have log base 4 of x times x plus 12 is equal to 3. And now I'm going to go ahead and rewrite this in exponential form. And when I rewrite this in exponential form, my base of 4 stays the same, so I have 4. What's equal to is my exponent, so it's going to be 4 cubed is equal to what's inside the log, which is x times x plus 12. 4 cubed, I get 64, is equal to x times x, which is x squared. X times 12 is 12x. Now I have a quadratic equation again, so I need all my terms on one side, so I'm going to subtract 64 from both sides. And I get 0 is equal to x squared plus 12x minus 64. And now I need to go ahead and factor this. And so when I'm looking at this, I'm looking for two numbers that multiply to negative 64 and add to 12. And those numbers are negative 16 and 4. Because negative 16 positive 16 and negative 4. Because 16 minus 4, I get 12. And 16 times 4, I get negative 64. And now I need to solve both of those. So I have x plus 16 is equal to 0. X minus 4 is equal to 0. So I have x is equal to negative 16. Or x is equal to 4. And now I need to check both of these solutions. And so when I plug in x equals negative 16 into here, I have log 4 of negative 16 plus 12 plus log base 4 of negative 16 is equal to 3. Well, I see I have a negative in here, which is going to be undefined. So I know this solution is going to be extraneous. Now when I plug in x is equal to 4 in there, I get log base 4 of 4 plus 12 plus log base 4 of 4. And I see both of those are going to be positive, so I don't have any issues there. And so that means that my answer here is just going to be x is equal to 4.